Hello and welcome again to Steve's Long Stay Vintage Radio Workshop, where stuff comes to looked at for various reasons. I've got another Eastern European radio here. This is from East Germany. Now, West Germany after the war gave us people like Grundig, but East Germany gave us things like this. This is a Weimar 680. Now, Weimar was in East Germany, and in days gone by I had a lot of influence too, but now, well, like I say, it's in East Germany, so this set comes from the other side of the Iron Curtain, like the last radio that I did. So as always, let's do what we shouldn't do, but I always do. Plug it in like that. Press the button or two. And see what happens. And it appears to be doing absolutely nothing, which, well, it did go up in smoke, did it? So something, I suppose, but there we are. It's not doing anything. So let's get into it and let's find out why. First of all, as always, like that. I think we'll probably take this plug off, actually, looking at that, and try it again, because it's not the healthiest plug in the world, is it? So I think we'll do without it. One thing which I sometimes wonder is which catalogue bought these in the day and brought them over here, because somebody obviously did. I've seen 2 or 3 of these in my time, and so what they were doing here in England, well, I wouldn't know. So let's have a look inside and find out what's happening with it. There are certain things which are common to all the Eastern European and Russian sets that don't happen on the Western sets. So straight away this is marked as a Eastern European set by certain things. So we do actually know straight away that it is such a set. I think it's marked up as being from Germany, not East Germany. So I don't know quite why that is, but there you go. It's marked up as being from Germany, the People's Republic thereof, you know, but Germany generally. So again, we don't know quite why that is, but I'm sure it doesn't matter, because of course a lot of the Eastern European sets, lots of technology was borrowed. There's certainly some cooperation went on between, say, Grundig and these mates, and firms like Electronica, of course, you know, were equally interested in. Oh dear, that's come off. Okay, well, that's nothing to worry about. It appears to be a set with a transformer, which is fine. Okay, so that's okay. That's okay. They're all in okay. And so the first place we'll look is this fuse here, which again might be past its best. Fair enough, it's dead. Okay. So that fuse has said goodbye to us. So I'll say goodbye to it. There we are. Now with that in mind, I think we should look to see if there's no really bad looking light for the transformer, and so if that's failed, then it's unlikely to be the valve, but it could be this milling capacity here. They do fail, so it could be that. I assume that's okay, although their capacities do tend to rather interesting in the way they fail. That is probably a UL84, again Eastern European manufacturer. So it appears to be in good, mucky but in good condition, which is what I like. But I'll do something with that in due course. But for now, I think it's more a case of making it want to play again on all bands, which is what it was made to do. So that's where we'll start with it. Yes, okay. And so somewhere in this there is a bit of a problem. That fuse might just have failed through old age. It's possible. It's unlikely, but it's possible. So what I'll do, I'll look around for another fuse to go in there. I'll probably put a big one in actually, so that if anything is happening, we won't go through small fuses like a dose of salts, you know. So I'll see what I've got, put one in, and we'll try it again. A 13 amp fuse has been put in place, better than most else, just so I can see what's happening when I power it. So power it almost, there you are, right, okay. Lights come on, okay. Heater up. That's too bright, that. Ow. Ouch. Right, well, that transformer is getting very, very hot. And this is getting a little bit hot as well. So it looks like we've got a transformer problem and a power supply problem with this, which is something which we can sort out without too much trouble. You don't have to be an exact transformer, but we know we need to let it cool down a little bit, and at that point I will lift out the EZ80. Come on, out. It's out right now. If we now put it back on again now. Still hot, that. Still very hot, that. Okay, so we know from that there's a problem with the transformer, which is something which we do have to worry about. By the way, that's on 220. Maybe it should be on to 240, but that doesn't affect it. But with that transformer, that rectifier out of circuit, I don't know what state that's in, but that transformer is past its best, shall we say, past its best. So the next thing we do here is get the radio out of the case and and then think, right, what we're going to put in there. Now, it's got a 6.3 volt winding for the heater. Got a rather sad looking EZ80 there. That might be okay, it might not, I don't know at this stage. That I don't know about. That I know for a fact is dead as a door knocker. I'm going to let it cool down a bit, and then we'll power it up again and see exactly where the problem might be on this. Well, here now I've got the thing out. I've bridged the fuse in an equally naughty way here for now, and with that out, that doesn't get as hot. That doesn't mean anything. I'll put another EZ80 in briefly, heated up and sparked as well, so obviously something not entirely right here, either with that or that. Now that does bleed like a capacitor, but I'm not happy with it, especially considering the stuff around it. So all that is going to come out, and I'm going to make this whole thing a lot simpler. A lot simpler because a lot of this actually is for the voltage which it's not going to be using. So we're going to get rid of that, get rid of that and this and that, and then we'll have some space to work in. But before I do that, always get some pictures of what's inside the set and where it all goes, because you're going to need that later on. Here, for example, there's the heater connections there, and there's the gets to the speaker, output transformer down to here. All goes down to here because output stage and power supply in these sort of sets are linked now. So I'm going to look first of all as to what currents all these take on H2 and L2, and find the transformer big enough to cope with it. And when I do that, it's going to come down here, and I will whip all this lot out. I can go out now, thank you very much, with preview point, and we'll take it from there, as the saying goes. This does look to me rather a bit, to be honest, but these things happen, so you know you can't complain too much, can you? Basically goes to here, and through here as well. So all that lot's going to come off, and the mains lead will go straight to the on-off switch. I think it's through here. I'm not sure exactly, but yeah, it goes through there. So that again, I will switch that around if it needs to be to the negative. For the negative, if it is that, to the positive rail, so that when the set is off in the front, most of it is dead. But always with a set like this, always make sure that when you're in the room, it's unplugged. I don't know what happened here, but something has. Now we could think all day about what that something is, and to some extent we might have to do that. But for now, I'm going to simply take all this lot out and take it from there, because there's really not much else I can say, you know, about it apart from that. Certainly a nice radio in some ways, but not in others. I'm going to modify the power supply on this as shown here. Not very well, but I'll talk you through it. Right, mains in, switch, transformer. Yeah, the transformer on these sets gives it two voltages, 6.3 volts to valve heaters and to bulbs on the front. That's fair enough. And the HT, first of all, it goes to rectifier. I might well put a big rectifier in here. Yeah. Reservoir capacitor. It goes to the middle pin of the 3 pins on the 8-volt transformer here, and from there, the biggest of the 2 halves of the primary goes to the anode of the EL84 there. This lot here goes to the second grid of the EL84 and the rest of the HT, the radio. It's simple as that. So rectifier, smoothers, transformer, that's what I'm going to put in its place. Simple, compact, and hopefully, despite that, easy to understand. I hope. Here, as you can see now, the transformer, the smoothing and reservoir capacitors and the rectifier have all been taken out of circuit. It's here. It's this lot, yeah? Now, that lot is giving all sorts of problems. I don't know about the transformer, but the rest of it does have problems. So, best thing to do, whip it all out, like that. And first thing we've got to do now is work out what is what here. Now, first of all, these two are to the front there, to the on-off switch for the radio. And we can check that by putting that on there like that, putting this on here, and it should make a noise because the radio is at the moment switched on. It is. Switch it off however, like that, and there will be nothing. Switch it back on, and there you go. So we know that's that. Okay. Now these two here, obviously these are the dial lights here, so we know what they are. And these, and here, this is the valves. Now the valves and the lights on this both go to 6.3 volts. So these are joined together and go to 6.3 volts of the new transformer that's going to replace this one here. Now if we look in here, like that, first of all it goes to there, yeah, and also from there it takes the stuff for the lights as well, off there, you see, so we know that's right. Now also here we've got this thing here which is probably knackered. I mean it's 60, 70 years old now. Transformer might be alright, might not, but I'm not going to risk it. I will check that in the future. So, you know, but I'll leave that there for now because I might need to refer to it. So the first thing we do is find a transformer, fit it in here, either way, it doesn't matter because the room in the case, I know that because I've looked earlier on. And then from there, we need, first of all, to put mains to it and see if we can make the valves on the front light up. If we can, then that's step one of the new loop power supply done. It's quite simple, but it has to be done in stages and it has to be done right, because if the power supply goes wrong, it can take the set with it. Now initially it had an EZ18 there. Now I'm going to place that with a bridge rectifier diode because it takes up less space and well, it's less load on the transformer, so it might be a bit easier that way as well. So first thing we do, however, is of course sort out the lights and the valve heaters. That's the first thing we do. So I'll go and get a transformer, replace that one over there, this one here, and we'll look at putting it in the cabinet. So I'll have a look, see what I've got, and we'll back with you in a jiffy. With a transformer like this, the primary and the secondary both come out of different sides of it. If you put it in the middle like that, that's the primary and the secondary. And the primary has different windings on because these two have the voltage circuit on the primary to set up for different mains voltages. That's why that's. But what I've got here now, you see, is I've got that and that are going to be cut back, and the earth and the furthest one away from it be the highest among all these. Basically, you go across it, and it'd be the highest two. One's going to be earth, obviously. Out of these, the highest reading one is the one we want because we're working 232 fossil volts here. Okay. Now, also on AM, therefore, on AC, by the way, we now have a situation where we've got where the 8 puts are hopefully going to be okay. Hopefully. Now put a meter on, which I'll just I'll just modify the camera so that you can see it. Okay, hang on. So there you see now it's set up perfectly well with mains going in, and this is the HT winding coming out. So if I was to do that now, 262 volts AC, by the way, that's okay, that's fine. Okay, so that's all right. Now, on these, you might think that the winding for the here is the main one. It's not. This is for the valve heater. This is the LT winding, which is actually much higher current, which is why it's why it's what it is. So now, if we put that on there like that and switch on like that, and put that onto there like that, we shall get. I'm afraid these wires need to be trimmed a little bit more, I think. Then we've got another faulty transformer here. Nice of it. It was okay just now, that. Not okay, I'll try the other way around. Oh dear, oh dear, oh dear. That's it. You see there now, you see it come up to something approaching. Yeah. Try that again. Let's say this one's bad as well. That's about sensitive because there you are, 9 volts. That's off load. That's off load. So with the valves and the lights onto that, it should be all right. So what we do now is put the meter aside for now. Bring this over here like that. That goes out of the way. And there's these here. Now what I'm going to do here, I'm going to put the valve heaters and the lights all across these two here. Now we should get light and we should get a valve heater and in here, and also, although it's not on camera, on there. So I'll do that, and again I'll come back to you. So just give me a sec, okay? Well, the lights I'm going to leave because the cables aren't long enough. So, hopefully will be when it's in place. If not, I'll extend them. But for now, if I with the connector up as so, all is going to be on this lot now is 6.3 volts or thereabouts. So in it goes like that, and straight away we've got the car lighting up, heater all lit. You can see it there, and there of course. So now with both of them lit up, hang on, I wonder if I can if I put one or two other valves in so you can see them. Hang on, no, I'll knock that off for a minute, right? So if I put in the EBF89, which is this one here, whichever way it goes, the start sockets do that, so which is a good thing in some respects, but not in others. There you go. Now with that in now, we should then be able to, that one should be lighting up as well. Let's see if it is. It is, yeah, it is underneath there. So now what we do now is we put the other valves in temporarily and see if they all light up. If they do, then that's the LT sorted. So ECH81, frequency changer, it should heat up as well. It does, okay, fine. What else have we got here? Right, there's I don't think we need one of those, quite frankly. EL84, an older but a goodie here. ECL82 actually in this case, so this one goes into here like so, and that should light up as well. Come on, there you go, lit up. And of course the EABC80, which I can now find and put in its place as well. I think it's this one, yeah. So EABC80 goes into here like that, and that should light up as well. Please light up. So there you see, all we've got on the set now is the HT. I'll go and knock a few lights off, so hopefully we'll be able to see it better with the lights down. So with you in a second, we'll do the money shot. Well, there, if you can see it, are all the valves nicely lit up and correctly biased, I hope. Correctly heated pinned, I hope. Now, one thing I will do at this stage, by the way, is check to make sure that the heater pins are at the correct voltage. It should be rated about 6.3, but we'll check, shall we? Better safe than sorry, isn't it? So I'll make sure that it is. Because the heaters are all in parallel on this, I can check them anywhere, but I'm going to check them at the transformer end, just for safety's sake. And it's about and that isn't right. It's probably this end, but something not quite right there. So I'll check and see. And there you are, 6.3 volts exactly. Once I sat down and got steady, 6.38 volts I think there is, isn't it, or something like that. So the LT on this radio is now happily sorted. So now we've got to look at the other side of it, the HT side of it, which is the one which gave us the trouble before. Now, the HT side of it, first of all, these here go to a bridge rectifier in this case. I'm going to put slightly less load on this by having a bridge. Doesn't really matter, but I think it might well be a good idea, so that's what it'll be. So then now, of course, we've got to get a bridge rectifier and put it on here, and then of course the first of the capacitors goes from the output of the bridge to deck, and then of course the bridge output goes to the middle pin of the two on the output transformer, which is over there. I'll bring that over in a minute. And by the end of that, the majority of that winding goes to the anode of the ECL, which is this one here, and the other half goes to the second grid of the panel side of this, and then down to the rest of the set, which is fairly simple. But I'm going to renew it all, because this and this on here I'm not going to use, because them again are 30, 60 years old, so I think we're probably better off with new kit, which is what I'm going to do here. So that is the next thing, is making sure that works. And when it does, with the speaker connected as well, we might even get some power. Well, first of all, while it's off, we need to know which of these here or here or here, these wires here, which ones go where. Very important we know that, so we know that, so we're going to find out. Okay, so, and that actually appears to be speaker cable of some kind, that, which is interesting. Yeah, anyway, so I'll get the bits, and we'll get the HT sorted, and we'll measure the HT before it connects up as well. Then we know the power supply side of it is mostly fine, mostly because another one of the smoothing capacitors goes on after the output transformer, so that's going to go back in as well. Now I've got the transformer linked up to a bridge rectifier. That's a full wave rectifier. It's a modern equivalent of the EZ80. So now if I put the thing on like that, straight away we should have about 300 volts across here, because I'll also put in the first of the two smoothing capacitors with our capacitor as well, so we should have on there now. Can you see that okay? Can you see that okay? I think you just about can, yeah. So now switch it to DC and go on there, and there you are. So that's the HT working so far. Now at this stage you've got to be careful here, because the HT from that rectifier has not gone anywhere apart from that capacitor. That capacitor is at the moment full of HT, and where's that going to go? If you touch that wrongly, it goes through you. So I'm going to leave that for me with a short across it to cool off while I get the transformer and the speaker up here. So then of course it'll I can carry on, and we've put up the output transformer and the speaker, but also I'm going to whip these valves out again, because this sort of thing is best done in stages, and you know, I think in a case like this has to be done in stages, because I don't want anything to go wrong here, because this part of the set is the part which generates most problems and can, if handled wrongly, do other things in the set. So mains transformer, bridge rectifier, reservoir capacitor, and the next part goes in there. Now when you do something like this, you've got wires everywhere, and because I didn't know them too well, I don't know quite which one goes where. Now, even if you do, it's worth checking. So first of all, we know that this one here, on the big rectifier, that one goes to deck. Okay, that one goes to deck. Okay, so that one must go to the chassis. That's one. Okay. Now the other one that we know about is this one here. Hang on, I'll move the camera down a bit. Hang on. That's the speaker socket, so that's yellow one that comes out just there, which you might or might not see on camera. That one there, that goes to the speaker, which is in the back plane down there. Okay, so we've got these three. Okay, now then, what else have we got here? Well, first of all, there's one which goes to the centre pin, is it like of the mains transformer, from here to the mains transformer. That one will come to when that comes over here. But the other ones, this one here probably goes to pin pin 7 down here. So it should go, if I'm right here, to that one. The meter is on that's okay, that's fine. Okay, so that one, I know this one here, it's screened, funny enough, goes to the anode. So that one goes out the main transformer to the anode. So there's one up there on the backboard which is this colour, okay, which goes down to there. Okay, so we'll note that. So first of all, we note that that one is the green one. Okay, now then, there's two more here. Now I know that one of them will go to the second grid of the transformer, which is I think it's go to the circuit and have a look. I think it's pin number 9, which I think is that one there. I think I'll just check. If need be, I'll put up. Okay. No. Okay, fine. Make sure. Okay. In that case, we'll try this one here, which goes actually through here. So it's more likely to be that one, but I'll check. I'll check anyway. So again here. Okay. So one of these therefore must go to a pin on here. Which one it is, I don't know, but one of them it has to. Okay. Be like that then. Sometimes you've got to think outside the box, as it were. So that's what we'll do now. Now that one goes to the capacitor up top as well, so but it goes to the middle of the pin like I said. So one of these here does go to the mains transformer. Which one it is, I'll have to check and find out. But at the moment, none of them do, which is annoying to say the least. Okay, try that one. So again, round we go. Okay, something's not. Something somewhere down here is not connecting. This might be a fault caused by the previous transformer. I don't know, but that one works, and that one's okay. But the one to the second grid of the 8-volt pentode here doesn't seem to be doing what it should. So it should be pin 1. So again, I'll check and make sure that goes onto there, onto there. You rotten little swine. You rotten little swine, you. So somewhere, I think here there's probably something that is not working. Anyway, these others, let's see what goes where. Well, that one goes to the deck, obviously. This one doesn't. Okay, fair enough. Well, this lot might be going up to the speaker as well, because the tone control goes from the speaker, so it might be that. But I checked this socket to make sure that everything is like it should be, and check it again in a minute. No, another thing you can do in this situation, sometimes the actual unit in question, the doesn't actually work unless you put a wire in and go to that. So I'm going to do that very quickly like that. Like that. And so that goes into there. It's that one. Okay, yeah, it's that one. Okay, so it's that one and that one are the two which hold the power, and so that one must be the one which handles the tone control side, which is on this in this here. Now, with that in mind, we now go and get the back bulb with the plate, with the speaker and the transformer on it, and look at those as well and find out again what's and what's not. I have now everything connected up. Capacitors are in place, the transformers in, both transformers are in, and so now if I was to do that and see what is where, first of all, there, that's okay, okay, so that's okay too, okay, fine, that's okay. So the voltages are leaving the transformer no trouble at all, which is exactly what I wanted. Now at this point I'm going to knock it off again very quickly like that and punch up the drawing for the ECL82 and make sure that all the voltages are there and one isn't, if you see what I mean. So ECL82, there we are, tube, right, and of course this particular one has voltages on pins 9, 7 and 6. So 9, 7 and 6. There's a fault somewhere among this lot, and so we resort to fault finding method. Now first of all, we know that the HT is getting to the transformer up here, yeah, and it should go out to 2 pins, 3 pins if it's ECL82, 2 if it's an EL84. What was in it was an ECL82. The diagram says an ECL84, but the one that's in it actually specifies EABC8 as well, which has an 8+2, so this had 2 preamp circuits, as it were, or that one is not where it should be. So I'll have to look further on that one and find out. So what I'll do, I'll put the speaker off for now. I'll check the output transformer, that's fine. So I don't know quite what is happening with the AT on this yet. Sometimes with these foreign sets you do come up with these sort of problems for various reasons. One of course being that it gives other problems. So yeah, so I'll look at the circuit, look at the wiring, and I'll find out where it is, and chances are where the resistance here might have blown, but I'll check that and see. You see, you do not with the pentode ever put volts on the second grid and not the anode. You don't do it, because the second grid will then act as an anode in a way, and so the pentode will act as a triode through there instead, which is not a good idea, and the pentode won't last very long. So that's what I checked before I put the valve in. Now whether the wrong one was put in the past, I don't know. It did appear to be in from new, so again I don't know, but we're going to have to find out. Yes, it seemed to have had the wrong valve in. I've put an EL84 in there now, and I checked actually by looking at the valve bases. An EL84 has the HT on pins 9 and 7. ECL82 also puts it on pin 6 as well. So what look at here is where it comes in to the valve from the one before it, and that of course is a different pin on each valve, and so for that reason I worked out from that it was an EL84. That's one way of doing it. So let's see what happens now. The power has just been applied. Power has been applied. So okay, no worries. Something else has happened here now, just like I expected. So I'm inclined to look very interestingly at that there. Now, interestingly in that that shouldn't be sparking, but it is. It doesn't actually do much else. So that is an interesting one in more ways than one. First thing we'll do is I'll give that a chance by just soldering it up better. Have that got it? We'll try that again and see what happens to it now. That's not getting at all warm, and nothing coming out of it apart from a few crackles. So let's have another look around that valve, shall we, and see what else might be a problem with it. A pentode, generally speaking, isn't a problem in that respect, but I think that next place to look is possibly the cathode resistor on it. If there is one, I'll just check. Yes, there is, so that's the place to check next. The power supply problem was my fault. I hold my hand up. I got two wires the wrong way around on the transformer there, so that is not doing what it should do. But now, at least it's acting, well, was acting at any rate, like something like this should, or was at any rate. So I'll check and make sure it still is doing. Oh, very kind of it. Okay, thank you very much. Yes, that's very this obviously decided not to do it on camera for us, so I'll just sort that out. Very briefly, like that, to hold it. That should hold it. And we'll try that again, shall we? So now, there should be voltages on more than one pin down here. I'll just check and make sure that there are, or is, depending on you. If you listen very closely, you now should hear a quiet buzz. If you come down here, like that, that shows the pentode side of it is working. Okay, so the pentode side of it does now operate. I noticed that the magic eye is not lighting up or doing anything, so it has got HT to it, so the HT is getting to the set fairly well, more or less. But if you look on the volume control here, there's very little. Now, what we must do at this point, therefore, is check and see if the HT has got 3 DC resistors here on the circuit, which drive the child section of the EABC80. Either one of those could have gone. So let's find them and find out, shall we? That's the next thing we do. So now we now go and find out about this valve here, because it's a no voltage to this valve. Of course, it won't put any output to the centroid, and I'll just make sure this is not going to come off again as well. There you go, that should hold it. There we go. Right, okay, now with that out, first of all, with the power back on, there should still be a buzz here, because of course when that comes up, there it is. Okay, now then, let's now go through here and see if we can find it. And it looks very much as though we can't, for one reason, not only to itself. Now, that means therefore that probably one of those 2 resistors has gone open circuit, which isn't a problem. Well, it is, but not a problem to sort out. So I need to find out from that where they are, and of course find out which one is gone. But first of all, I'm going to tidy this lot up here, because it's a mess, and it's well, it's a mess. Now these here are not used, okay, so that transformer is going to go off there and go onto there, and so that too is going to go mounted on the chassis somewhere. Okay, so now the next thing we do here is make it all a little bit neater. As you can see here, things have not gone cut together and worked quite rightly. As soon as I put the original transformer I got in on the case here, it stopped working. Now I went in my stock of transformers and got some Murphy transformer out. I thought, sure, that'd be alright. It wasn't. Dead primary, the same way as the one that was in here, and so that went up. This is from a KB, and this one appears to be alright, but because of the situation I've had, everything is joined up at the moment with Wago connectors. Very handy things, these. Get a lot of trouble, and also make things such that you can actually, you know, take things apart and check them. And this was okay last night, but not this evening now. And the reason for it was basically a piece of wire. Yeah, all the problems with this so far have been down to a piece of wire. I kid you not. The circuit on this shows that the anode of the EL84 to the output transformer here is a screened lead, which is fair enough. Doesn't really need it, but it's there, you know. And I found that was intermittently going short circuit, and also the transformer itself, for some reason, it didn't want this capacitor here going to it. So the transformer now here, the output from it is okay, but that case is not earthed. The earth is there and it goes down here, so I'll leave that capacitor where it is. The other one that was there, the tone correction cap, I whip that out. Sometimes it's easy enough to do that. That's okay. And now if I was to give it some power and wait a minute while it all warms up by itself, and get something to probe with, like that, you see. That tells us that the 8-point transformer on this is working. But there's nothing else anywhere. Nothing else anywhere. Now, if you look down here, a while ago I talked about these EABC80s. Sometimes one heater inside them fails. Because if you look at the EABC80, which is this one here, if you look inside, the three metal pillars, as it were, inside there, you might be able to see it there. See it better that way, I think. Yeah, one of them doesn't appear to be lighting up. Now that means, therefore, that the volts going to that the preamp circuit on this, the first amp circuit, I've got nothing coming out to the end of it. Now if that happens, then of course no audio at all, nothing, no volume and no nothing. So I will quickly now, I'll quickly get the EABC80 and we'll try it. You know, nothing's easy in this world, is it? The EABC80 I put in was a Costa version. That didn't improve matters at all. Now, looking at the diagram and the circuit, the signal goes out on pin 9, the anode, the triode. It's triple diode triode, which is something that you know, you try to say that when you paste. Anyway, so pin 9. As you can hear there, it's picking up the audio, but there's nothing, but the volts on that pin are 0.12 volts. So the problem is not the valve. Well, it might be the valve as well, but also there's something as well coming up behind it. Now look at the circuit, which I can do now like this. It actually goes through electric, through the capacitor of course, and also it goes through 2 resistors and electric to earth as well for the voltage. So either one of those resistors could be faulty, or most likely actually the capacitor, the electrolytic. So but I think the best thing to do here now is try again and put these things together neatly, well, neatly enough so I can turn it over, have a look underneath and find out what's where, you know, and find out where that fault is. The transformer is in and working, but as I said, there's nothing coming out of the EABC80. Well, there's nothing coming out of it for the rest of the set. Now, if we go through the EABC80, pin 9 is here. As you can hear, there it is. Okay. Now, EABC80 pin 9 has a voltage which is not there, as you can see on the meter there. Oh, you can't, can you? Hang on. Can you see that? Yeah, okay. Right, so now, there, it's 270 volts. It's a bit high, but don't worry about that. Down here, like that. Down here, like that to there. And to there. Or to there. Goes to there or to there or wherever that this goes. There's okay. There isn't. There isn't. There isn't. So obviously everything around there is now almost completely dead. Again, going back to the EABC80 pin 9 here. It's got something like 3 volts, which is obviously not enough. Now, in this case, if you look closely, there's something got onto this board causing a little bit of a problem. You can see, if you look here, you see it, just down there. What is that green stuff? And are those traces working? And if they're not, well, it won't get very far, will it? So going on to the diode check, like that. That's okay, yeah. And it should go around here. And it doesn't. Also, if we go onto here, like that, and go down to here again, it's there, but I don't trust that. Okay, so that middle one is obviously causing a problem. Now here, of course, the other one, there's a component here which obviously needs some work as well. So if you put yourself back on again for a minute like that, and let's check that again to make sure that I'm thinking straight. Okay, so plenty there, nothing, nothing, nothing. So the problem is obviously, looking at that, it's more likely to be getting there, but no further, as you can see. And whether it's components or whether it's the switches or what, I don't really know. But in actual fact, there shouldn't actually be any anything there going through the switch. So that again is rather worrying. Just to check here, this valve here, what's this one like? 57 volts. Okay, that one's okay. It's got voltage on it. Okay, fine. So if need be, we can pick it up from somewhere else. And here, this should be. It's okay. That's okay. $72, okay. $29. So I'm not too happy with that voltage there either, to be honest with you. Now the UCC or ECC, in this case it's ECC85, goes on here. Now at this stage I'm inclined to leave that for now and see. But first of all, I think the next thing we do is sort that out there, because that looks pretty bad, and it looks as though it's been allowed to rot over years. So those, I think the thing to do there is to clean the whole thing off and see where it is, where it's not doing, and that sort of thing, because that is of course next on the agenda. So now of course we've got to look down here and clean that up, whatever it is. What I've done here now is I've cleaned that up there, and the one that is actually open circuit, those are actually okay, I've cleaned them up, and like I said, I've placed the one that's open circuit. Now I don't think that will cure the fault, but never know, so we'll see. Now at the EABC80 here, everything's warmed up and working. There's the hum. Well, as you can see from the meter, there's nothing else at all. Nothing. Still nothing there, which is what's expected. Now, the circuit diagram for this set does not contain the values of the resistors here at all. And I can't actually get any reading from anywhere from there. Not to deck or anywhere. So if the capacitor has gone, then there's not much... we're nothing getting to it, so it's interesting. Now in this situation, wait, what I'm going to do is cheat basically. Now, if you want to know the correct value of a component like this, in a set like this, then the thing to do is you go to another set, get the other set, or the diagram at least, which is here. These boots are very handy because you can loop from set to set. And I noticed that the Ferranti one puts it on at 74 volts, and 220k and 4.7k, so that's 220k or thereabouts. That's one. Okay. Now going back further along to another set of a similar kind, ACD, not AC on these, ACDC, because these are ones with the transformer, which I had a lot of fun replacing earlier on. So now we find a set with the transformer in it, another one, and see what that is. I'm looking for specific sets here. Specific sets. Right, okay, so Costa, EABC80, it takes 60 volts, okay, fair enough, and it goes through two resistors again, and again it adds up to the same sort of area. So basically we're looking for about 200k or thereabout, judging by this. So what I'll do, I will go and I will find a 200k resistor, put it in there, maybe slightly less, maybe put slightly more behind it, and see if then with that on there we actually get any signals through. So time to look at resistors and find out what's what and what to use. Right, I'll put a resistor in straight to the anode of the EABC80 here. So now if I was to do that, like that, first of all we'll start here. Which should go up like that and come down, which it does, okay. That goes there, that goes there, and it's only 54 volts here. The valve is not in at the moment, so it would be higher than it should be. But the EABC80 takes up to 250 volts, so now if I put the EABC80 in and let it warm up, and we'll see what it does. Let's see what it does and says. It doesn't do and doesn't say. Okay.
victory for Andrew McKenna. Argentina's best passage of the game has resulted in Thomas Cubelli, the Argentina scrum half, diving over from close range. It was converted by the Felly, so it's 16-10 in favour of England with 2 minutes to play at this first half. It hasn't really been Richarlison's night so far, just given the ball away on halfway and out for a throw on the far side of Crystal Palace. And Postecoglou wrapped up in his...
That seems to be working okay now.
That's the same Mac that he was wearing on Monday night.
So I'll let it run for a bit and make sure nothing else shows up, because it might on this.
In the right format position, up over the halfway line it goes. It's won by Gay, and then chipped down that left ward, who's happy to run in behind.
The EAB's is fine on all 3, by the way, as is Luke now, so.
Exciting. Strancer on the bench, available to them, but Roy Hodgson reluctant to use him from the start, despite a good cameo last week against Newcastle and a good performance in the under-21 game earlier in the week where he played 45 minutes. Picks the ball up onto the halfway, dragged to the floor by Van Sar. The referee is allowed play on quickly and they're taking the free.
Right, I'll let it run for a bit and make sure that everything's settled down before we tackle things like VHF.
It's still all the way back.
Oh, and I'll put that back as well, the antenna.
Planned initially, Johnston forward.
Next, of course, before I start gluing things up, putting things right again properly, it's always wise to check VHF. Only thing that goes on with VHF sets, in most cases, not all, is this valve here, an ECC or UCC if it's an AC/DC set, ECC 85. In most cases. So if you do that, we know that that's working okay, because that's at one end of the dial. There's two ends to dial on this, and there's classical mutation at each end, so it's easy to check. So now, of course, we've got to sort out things like, first of all, why isn't this doing anything? Because it should be doing, as you can see here. Switch to VHF, and we'll switch if it does come to life. And it doesn't, so yeah, so now it's basically charging up. I might leave all these in place actually, because if a more suitable charge transformer comes up, then I can whip it and put something in which is better suited. But now, of course, it's tidy up and generally make the thing more comfortable again. These radio connectors, they are very good actually, because they let you swap by the bait if need be, if you fault find it, if you want to pull things off. It's easy to do, which was difficult in this case because of course I had a problem caused by a piece of wire. Just close to show you, doesn't it? Right, well, as I'm waiting for something to come to hold that antenna rod in place, I've done 2 more things. I've secured that in place there, that's okay. Now, as far as the Magic Eye goes, first of all, on the back of any Magic Eye, there's the resistor there, yeah? And that resistor is about 470 K, yeah? But it goes up in value. In this case, it went up so high that the meter here couldn't read it. So that's why the thing wasn't working. So I changed that, and it came up, but it was very dim. Now, these valves last very well, but some fail more than others. There's a mod one I've put in here, which I got from Goldborn yesterday. And if I was to do that now, wait for it to come up, you see now it's a lot brighter. If you can see that or not, but it is. Hang on, I'll. There's the audio. So from that, you see that is now working. Now also, when it comes up properly, it doesn't go all the way across. I don't like them to, because basically they are to check the level that's coming in, and if it goes all the way across on anything, then it can't do that very well. So I like them like this to be back a bit. So this one is now working. I think it comes on the camera. I'll check it and see if it does. I'll hold it up so you can see. There you are. You can see that.
The Premier League fixture on the 24th of December in 28 years. Afghanistan have kept alive their hopes of making the semi-final of the Cricket World Cup. They beat Sri Lanka by 7 wickets. After 6 matches, they're 5th in the table, just 2 points behind New Zealand and Australia in 3rd and 4th. And Andy Murray's rotten record against Alex de Minaur goes on. The Scots suffered a 6th straight defeat to the Aussie, throwing away a 5-2 lead in the deciding set at the Paris Masters. Talk Sport News.
So it's there, but it's not going very high. Also, I've got to sew that back in properly as well. So, but it's all done actually. The next thing we've got to do is put this thing back together again. That'll be fun. Finally, this set is working. Finally, because of all the trouble it's had. 3 transformers for the same one that worked with it, or worked at all actually. A piece of wire was faulty. That was the cause of all its problems. Smoothing caps have been replaced. The resistor on the back of this is EM84 and the oil itself have been replaced. Do be careful of that, by the way. And that really is it, you know, so it does actually appear to be working rather well.
Both teams knocking the ball around, zipping it around off the surface and counter-attacking with
that is actually AM. That is actually AM. If you go to FM, and it does that.
Liam in West Somerset tonight, Gaff in Northampton, Paul in Auckland, locked in, ready to discover brand new music. That's how it works out here. Into the depths of what this planet has got to offer in terms of the future of music, this is the place to be as well. Loads going on throughout the rest of the show over the next hour and a half. Around about 9 o'clock tonight, we are going to be introducing you.
And that is Radio 2 there. Running, of course, off the meter probe rather than the set itself. So now the set is actually working again. I've got another problem. That problem, getting it all back into the cabinet and working there as well. These I'm going to leave because if a transformer comes by that does this job better, I can put it straight in. So these I'm going to leave in place just for that sake, you know. So what I'll do another thing with these, by the way, that it comes in very useful, is that you can in fact disconnect the output like that from the rest of the radio, which is very useful because at that point then you can now go and say, right, okay, well I'll put that in the cabinet and put that in the cabinet and switch it back up, put it back on, and see if it works. If it does, great. If it doesn't, I shall swear. Well, here we are now with the set together again and working, as you can see. If I was to do something like that. This is an East German radio, and these German sets, this was obviously based on a Grundig. That's pretty obvious, judging by a number of things inside of it. Tone control work and everything else, so it does work. as you can hear, rather well. You see it on camera, you see the magic eye works now as well. So this radio, therefore, has a clean bill of health now. So there you go. Anyway, there it is. These East German sets, they are very good. With these, I must say, it's resisted well the capacitors which fail on these. I don't know if the original transformer did need to be replaced, but it was, because a whole lot went up in there. So no, but it works now, and so there you are. It works. End of story. So until next time, here on Steve Pendlebury's Vintage Long Stay Workshop. Have a good time, whatever you're doing. Be safe, don't blow yourself up, and of course, keep fixing radios. Bye bye.
I've been trying to impress that more is less and I'm repressed.